Good morning, students. Last class we discussed about the laws of refraction, definition of refraction, and some condition related to the refraction. Okay, what is meant by refraction? When the ray of light travel from one medium to another medium, so it bends, it passes obliquely. So that bending nature of light is known as refraction. Okay, why that light bends? Because due to the velocity changes in the medium, due to the velocity changes in the medium. If we take two mediums, one is air medium and another one is water medium. Okay, now it is the normal ray, and this is the incident ray. AO is the incident ray, N dash is the N dash is the normal ray, and OB is the refracted ray, and angle AON is the angle of incidence, N dash OB is the angle of refraction. When the light travel from one medium to another medium, means heterogeneous medium, it passes obliquely. It passes obliquely, or we call it as it bends. It bends when it travels from one medium to another medium. Okay, so due to the speed of the light in the different mediums, due to the speed of the light in air is different, and also the water is in the water, the speed of the light in water is different. Okay, I already told about the optical density. When there is a variation in optical density, means air optical density will be vary compared to the water. What is the difference between the optical density and the mass density? Optical density is vary with the mass density. Mass density is mass by volume, and the optical density is considered about the speed of the light in the different mediums. If the speed of the light in the medium is V1 and the another medium, the speed of the light is V2. Okay, so there is a variation in speeds, so according to that the optical density will be differ. Okay, if we take one example like turpentine is used to clean the brushes, paint brushes, like that. So that turpentine is will be it floats on water, means density of water, mass density of water is greater than turpentine oil. But optical density of turpentine is greater than water, means turpentine optical density is greater, means more than the water. Just means if the water is one medium and turpentine is the another medium, this is the rarer medium and this is denser medium. That's why, so the optical density is differ from mass density. Here, if the light passes from one medium, it is now water is rarer medium and turpentine is a denser medium. When the light travel from one medium to another medium, means when it travels from rarer to denser medium, it bends towards the normal. Because the speed of the light is lesser than the rarer medium. That's why that the speed of the light will be vary. That's why that bends towards the normal. If the light travel from If it is a denser medium, then it is a rarer medium. If that light travel from denser to rarer medium, also light takes refraction, right? Light takes place refraction. Now if it is travel from denser to rarer medium, it bends away from the normal because the light of the light speed in denser medium is more than in the rarer medium. That's why here the angle of incidence is lesser than the angle of refraction. Here R is greater than I. In the case of water to turpentine, here the I is greater than R. Okay, I is greater than R because due to the different in optical densities. Okay, now we move on to the another condition, that is Snell's law. Snell's law means the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. That constant is called as the refractive index for a given pair of media. Refractive index is nothing but it is mentioned it as n. Okay, so it is a constant. That constant is called defined as, according to Snell's law, it is the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. That constant is called as the refractive index. That constant is called as the refractive index. Now the meaning of that refractive index, that is explained in the terms of speed of light. That is absolute refractive index, or simply we call it as refractive index. Absolute refractive index. This is called as the Snell's law. Now I will explain the meaning of the refractive index. That is absolute refractive index, or generally we call it as refractive index. The refractive index, it is defined as the ratio of speed of the light in vacuum to the speed of the light in medium of the given medium. Means we compare the one medium is now I will take absolute refractive index. It is taken to be, now vacuum is the one medium, that is rarer medium, and air is the denser medium, or air, or it may be a water or any medium. Now it becomes vacuum, or next another medium is air medium. Now absolute refractive index, it is defined in terms of speed of the light. It is the ratio of speed of the light in vacuum. What is the speed of the light in vacuum? That is speed of the light is vacuum is, that is 3 into 10 power 8 meter per second, or 3 lakh kilometer per second. So now n is equal to c by v. V is nothing but speed of the light in the medium, any medium, not only the air, water, glass, anything. Okay, we will compare the speed of the light with respect to the vacuum. So that is the absolute refractive index, that is defined as the ratio of speed of the light in vacuum to the speed of the light in given medium. Okay, now if we consider a vacuum, or shall we take another example? Okay, now if we consider air and water. Okay, air is refractive index 1 and water refractive index is n1, and water refractive index is n2. Now if we compare the refractive indices between the two mediums, n1 is the absolute, N1 is the absolute refractive index of air, and N2 is the absolute refractive index of water. Okay, water or any medium. Now we consider the water as the medium and air as the medium. Okay, now absolute refractive index. Next, another condition is relative refractive index. Relative refractive index. Relative refractive index. Relative refractive index means we will compare the mediums with respect to the refractive indices. With respect to the refractive index, we will differentiate the mediums, that is N12, or it is mentioned it as 1N2, or it is mentioned it as N21. So now we have to differentiate the mediums with respect to the refractive index, that is, one is air medium, we will consider that refractive index as N1, and water as the second medium and its refractive index as N2. Now, general refractive index formula is, absolute refractive index formula is C by V. Here it is a two mediums, then N1 is equal to C by V1. C by V1, N1 is the refractive index of the air medium, means N1 is the absolute refractive index of the first medium, and N2 is the absolute refractive index of the second medium. N2 is equal to, N2 becomes C by V2. C by V2. So we will compare with the speed of the light in vacuum, that is the absolute refractive index of the first medium, and N2 is the absolute refractive index of the second medium. Relative refractive index means that is mentioned it as 1N2 or N2 1. It is in the subscript. It is defined as relative refractive index is defined as absolute refractive index of the second medium with respect to the first medium. It is defined as the ratio of absolute refractive index of second medium to the absolute refractive index of the first medium, that is N21 becomes absolute refractive index of the second medium to the absolute refractive index of the first medium, that is N2 by N1. Now if you consider these formulas, N2 means C by V2 divided by N1 means C by V1. Okay, CC gets cancelled, then it becomes 1 by V2 divided by 1 by V1. Therefore, it becomes V1 goes to the numerator, then it becomes V1 by V2. Here that is N21 is equal to V1 by V2. It is the relative refractive index of the first medium and the second medium in terms of velocities, or it is N2 by N1, or it is mentioned it as N2 by N1, or sin I by sin R. Okay, so these are the formulas related to the relative refractive index second medium with respect to the first medium. Now we will write the another formula, that is N12. N12 can be written as, it is defined as, N12 can be written as, that is V2 by V1. That means refractive index formula becomes relative refractive index of the second medium, first medium with respect to the second medium, that formula becomes N1 by N2, that is equal to V2 by V1, V2 by V1, that is equal to sin R by sin I, sin R by sin I. So this is the absolute refractive index of the two mediums, any two mediums. This is the absolute refractive, means relative refractive index of the second medium with respect to the first medium, and this is relative refractive index of the first medium with respect to the second medium. So these are the formulas. So that is N12 becomes N1 by N2, that is equal to V2 by V1, that is equal to sin R by sin I. Here that is N21 is equal to V1 by V2, N2 by N1, that is equal to sin I by sin R. So these are about relative refractive index of the, why we require this relative refractive index. That means it gives the idea about how that light bending takes place. Here the water is a denser medium, air is a rarer medium, then how much that will be bending takes place, that we know about by using the relative refractive index condition, and also we measure the speed of the light in the two different mediums. Here they will given if a given some problem, okay, here speed of the light can be given, we know the speed of the light, and in the water medium they will give a speed of the light in the water, then easily we calculate the relative refractive index. Okay, there is no unit for the refractive index because it is a coefficient. Coefficient means there is a same quantity in the numerator and also denominator, that's why it will be cancelled. So that's why there is a no unit for the refractive index. Okay. Next, coming to the another condition, that is lateral. Next topic is lateral shift. Lateral shift. Lateral shift. Lateral shift, it is the first we will consider the glass slab. Glass slab, above that there is a air medium, and this is the glass medium. Air is a rarer medium of refractive index N1, and glass is the denser medium of refractive index N2, and below that there is a air medium, then it becomes a rarer medium and its refractive index once again it becomes N1. When that light path we will consider now the path, first we draw the normal for the first surface, top surface. Okay, this is the top surface of the glass slab, already you saw that one maybe. Okay, so here is the first medium. When that light incident, it is the first medium. When light passes through the another medium, it becomes the medium 2 or the second medium. When the light incident on the glass slab, when the light incident on the glass slab, it is the normal, it is mentioned it as NO N dash. Okay, AO is the incident ray, and AON is the angle of incidence, Okay, now when that light travel from air to glass medium, means rarer medium to the denser medium, it bends towards the normal, without changing the medium. There is no refraction here. Totally glass medium, there is no bending nature, it passes through straight because due to the rectilinear propagation of light. Okay, now this is the angle of refraction. Then OB is the refracted ray. Okay, now it is as usual, it is the first medium and this is the second medium. When that light travel from one medium to another medium, light bends. Okay, now coming to the another surface. Now it is a glass medium and below that there is a air medium. Once again it takes place refraction due to the difference in media. There is a glass medium and below that there is a air medium. It passes through that. Then once again we will draw the normal here, okay, for the second surface. Here NO N dash. Now I mention it as PP dash is the normal for the second surface. N dash is the normal for the first surface. Okay, now here when light travel from rarer to denser medium, light bends towards the normal. Then if it is a glass medium and air medium, another medium, glass is the denser medium, air is the rarer medium. When the light travel from glass to air or denser to rarer medium, it bends away from the normal. Okay, see here in the glass slab, two times refraction takes place. One is when it travel from air to glass, one time refraction, and glass to air, another refraction. Two times refraction takes place. Observe here, it is the incident ray. If we extend the incident ray, this incident ray, extended incident ray, it is parallel to this is the emergent ray. If we extend the incident ray, which is parallel to the emergent ray. Okay, now if we take the perpendicular distance means if we draw the perpendicular between these two lines means one is emergent ray and the incident ray extended. This perpendicular distance is called it as lateral shift. The perpendicular distance between the incident ray extended, extend ಮಾಡಿದೀವಿ. Okay, extended and the emergent ray. The perpendicular distance, that perpendicular distance is called as the lateral shift. Here also same distance, here also a same distance. Here it is mentioned it as BQ. So BQ is the lateral shift. So that is mentioned it as LS, that is T sine of. The formula for that, there is no derivation for the lateral shift. That is T sine of I minus R divided by cos R is the formula for the lateral shift. So LS is the lateral shift. Lateral shift means sidewise, that the object will be appear sidewise. If we know the different type of phenomenon we will observe in the nature, that is when we saw the bottom surface of the swimming pool, it appears will be up. If we catch the fish in the water, so that will be means it looks like above the surface. If we catch, there is refraction takes place, but the fish in below the bottom surface. So due to the refraction it takes place. Okay, so here lateral means side. Okay, shift due to the refraction when the two mediums occurs, there is a 2 times in the glass slab particularly, there is a 2 times refraction takes place, means lateral will be shift. That the image looks like when the object is here, but it object is exactly here, but the image will be up here on the another side of the glass slab. Okay, based on this condition, okay, so lateral shift, that is the perpendicular distance between the incident ray extended and the emergent ray. So that distance, perpendicular distance, is called as lateral shift. For that formula there is no derivation. For that formula, T sin of I minus R, I means the angle of incidence, R means the angle of refraction. Okay, T means the thickness of the slab, T means the thickness of the slab. Okay, thank you.